Good afternoon. I'm hoping that this recording will help you better prepare for any future tasks. This is just a solution of a quadratic and cubic, actually, that we were looking at recently. Now, just so that you're aware of the positions, we have a building. This is at 0, 0. We have a tree at 24, 9 with a radius of 3. We have a building position B, which is 60, 10. Now the criteria states find the equation of two possible parabolas along which the wall could be built so that they meet the conditions of passing through A, passing south of the tree, passing to the north of a fence. The fence is 4 meters below. Joining smoothly at the point 24, 3. Now 24, 3 is below 24, 9. That's 24, 6. It's 24, 9, so that's 24, 3. And smoothly meeting the front wall. Now, smoothly meeting the front wall means it's going to be coming in level. And we want two possible parabolas. So we want a parabola that levels out here and passes through that point. So we've got a point, 24, 3. We've got a point, 60, 10. And we've got a gradient. There's three conditions, and we can need three variables. That's all we need to know for that. The other one is it passes from here and it passes smoothly through there. Now, the parabola here is going to be smooth at that point. So the derivatives match. The derivative here matches of this curve matches the derivative of that curve at that point. We don't know what the gradient of that curve is, so we're going to start with the second parabola because there are three conditions which we do know, and there are 1, 2 conditions that we do know here, plus a third condition which is to do with the gradient. Well, let's have a look at what all of these conditions are, because I want to put them into the calculator and come up with I want to say the first parabola is ax squared bx plus c. I want the second parabola, I'll just call that y1 and y2, to be abc dx squared exf. So that's the second parabola. Here we're going to be going from 24 up to 60. And here we're going to be going from 0 up to 24. Best not to have 2 less than or equal to. If we have hybrids, just choose one of these to have the equal. I'll choose the first one. Okay, first condition. It passes through 0, 0. So we would get 0 equals a times 0, b times 0, plus c. Therefore, c equals 0. Okay, we already know that c equals 0, so we know what that variable is already. So the second condition is 24, 3. So it passes through 24, 3. Therefore, 3 y value is a times 24 squared, b times 24 plus 0. And this equation over here also passes through 24, 3. So 3 equals d times 24 squared, E times 24. We don't know F because this is a different constant over here. So we've got 3 equals 576A plus 24B. Let's just call that equation 1. And 3 equals 576D plus 24E. Let's call that equation 2. Now 6010 satisfies the second equation, so 10 equals D times 60 squared, E times 60 plus F, so 10 equals 3600D plus 60E. And let's just call that, well, plus F. Let's just leave that as equation 3. Okay, so we've got 1, 2, 3 equations. There's our, that's this condition, these two conditions, and which we've got one condition finding C, one condition here, and these two of these conditions, but the third conditions are gradients. So let's say that the gradient of this equation, the gradient equals 2dx plus E. So if we substitute, we know that there's a gradient 0 at 6010. So 0 equals 2d60 plus E. So 0 equals 120d plus E. So there's a fourth condition. Now the gradient of this equation is 2ax plus b. And we know that the gradients are the same, this condition here. So the gradient, which is this condition at x equals 24, will equal this condition at x equals 24. Therefore, 2a 24 plus b will equal 120. No, where is this? Where's the gradient? Not that. That's not the gradient. The gradient's up here. It will equal this at x equals 24. So it's 2d 24 plus E. Okay, those gradients will equal. Now we've got this condition here. Okay, I just want to now use the calculator, right? Because we've got our pen and paper equations. If we plug these 5, 1, 2, 3, 4, and 5 into the calculator, I will get this condition here. Let me just move this around, get the keyboard. Now, the first condition is 576 plus 24, b equals 3. So I've typed that first. The second condition was 3 equals 576d plus 24e. 576d plus 24e. Oh, you probably saw that. I left out the plus f here. Can't do that. All right, plus f. The third condition is 3600d plus 60e plus f equals 10. So we got 3600d plus 60e plus f equals 10. The fourth condition was 120d plus e equals 0. So that's, I've put this here, 120d plus e equals 0. That should be a variable e, but it worked on the computer. And the fifth condition, which is underneath here, 48a plus b equals 48d plus e. So 48a plus b equals 48d plus e. Now, the 5 variables are A, B, D, E, and F. Okay, we've got the 5 in this bracket here. We've got the vertical line here, and we press done. Now, therefore, we've got A, B, and C. A is 19 over 728. Uh, 1728. B is negative 5 over 36. C is 0. D is negative 7 over 1296. E is 35 over 54. And F is negative 85 over 9. And they don't want us just to write the coefficients, they want us to actually write the equations of the two possible. So the equations are, and I'll just put it up here, y equals 19 over 1728 x squared plus negative 5 over 36x. That's equation 1. And the second equation, I'll put y2, is negative 7 over 1296 x squared, 35 over 54x, negative 85 over 7. So you see, the pen and paper requires us to set out, substitute, and come up with the different equations that 24.3 satisfies that equation, 24.3 satisfies that equation, 60.10 satisfies that equation, the gradient is 0 at 60.10 for that equation, the gradient of the first parabola equals the gradient of the second parabola when x equals 24. Once you've got those criteria, you then plug it into the calculator, let the calculator talk, and then collect the two equations. Now, it said write this as a hybrid function. So to write it as a hybrid function, you simply write f of x equals, and then you put your two equations. The first equation, 19, 728x squared minus 5 over 36x, and you put x is between 0 and 24. The second equation, negative 7 over 1296 x squared, 35 over 54x minus 85 over 7, and you write the from 24, not just less than there, not at less than x and less than and equal 60. Okay, and so there's your hybrid function. Sometimes they just sort of put an equal comma there. They don't need a semicolon, but just a comma would be fine. Okay. That will do for this recording. I might make a separate recording for the next one, because that one may have introduced some new complications. All right, so until I talk again, stay happy.